Well, everybody looks good today. All right, we're live. Welcome to ScaleUp Heroes. We're up to episode 18 every Monday. You can find us here at ScaleUp Heroes. We bring you the best minds with the best real life experiences when it comes to scaling up businesses. These are the heroes that took on the difficult odds. They're living to tell the tale. And to all of our viewers, we invite you to visit our website, ScaleUpAcademy.io. Today, we're talking about scaling up engineering. And so we welcome our viewers, our guests to the show. I want to introduce today's moderator. He is Paulo Almeida. He's the VP of engineering at, and I'm going to butcher this. You told me what it was. Help me, Paulo. What is it?
At Pomelo Fashion.
There you go. And he's coming to us from Bangkok. I'm in Dallas, Texas, and I'm not bilingual. English is a tough language even for me. So welcome, Paulo, and the rest of our guests. I'll let you take it over.
Okay, thank you, Randy. Hi, everyone. I guess we can start with a quick introduction of our own companies and what are our responsibilities and more or less the size of our team. I can start with myself. So Pomelo Fashion is a vertically integrated fast fashion company that uses omni-channel. What that means is that creates a seamless experience between the offline and the online, mainly using technology and all the customer experience and customer behavior that comes from behind it. So what I'm mainly responsible right now in my company is responsible for the product development, strategy, roadmap, also the technology vision. There is a cloud infrastructure that needs to be supervised, a retail infrastructure for our high-tech shops. And there's also an IT help desk / support for the entire company that is more or less around 300 people. Currently, the engineering team is composed of 25 to 30 people, among several pieces between product management, UX, plenty of developers, and a couple of IT help desk / support. We're currently between Series B and Series C, so it's one of those stages where you kill or you get killed. So everything is on board and the commitment has to be 110%. So leaving you a little bit on that note, I guess we can start with Paweł. Paweł, you want to share us?
Hi. Yeah, sure. So I'm Paweł. I'm the CTO at Pusher. And what Pusher does is we provide real-time collaboration and communication APIs for web and mobile developers. For example, our core product is a PubSub message bus for web and mobile applications. Examples of our use cases include, for example, New York Times used us to power this kind of nice little emoji tracker of emotions during the presidential debate in US. We've got other customers like Financial Times using us for live stocks. We also have several other products that are nearing general availability. So Beams is our push notification service. ChatKit is our chat solution. They should soon be ready for general use for production workloads. What I do at the company is I'm responsible for identifying and promoting technologies that help us build better products and build them faster. That's pretty much what I've been doing recently. The company is around 70 people now, around 30 in the engineering team. We've got around 3 product teams, 3 small platform teams that are building the common foundations for the new products. We announced the Series A funding in April from Moderator Capital, so we're growing. We'll be hiring. We're launching a new office in San Francisco. So, yeah, things are accelerating, and we're trying to get some new products out.
Okay, that sounds exciting. Alexey, do you want to go next?
Yeah, sure. Hi, guys. My name is Alexey, or Alexey, as Paulo said. I'm a director of engineering at AppLift. AppLift is a mobile advertising company. So what we do, we lift advertisers up and basically fulfill all our advertiser needs in terms of mobile marketing. AppLift was founded in 2012. We are, I think, around 200 people. At the moment, our tech team in total comprise of 30 to 40 people right now. We're based in 2 locations, Berlin and Bangalore. I'm responsible for a team that has the attributes, or runs the products that has the attribute of so-called real-time. If you can think of it as a performance marketing tracking, it's various data pipelines, which is connected to data collection, aggregation, and distribution to internal and external clients. I'm also responsible for driving the whole cloud infrastructure that drives those products. And our flagship product is DataLift 360. This is something that gives advertisers a unified solution for all the app advertising needs. That's pretty much it.
All right, that's not small. Eduardo, do you want to go next? Maybe you want to unmute yourself.
Now, hello, I'm Eduardo. I'm CTO at Packlink. I've been working here at Packlink for 4 years now. So Packlink is a shipping platform that helps businesses and users alike to ship. Shipping is a complex business. So we take advantage of technology to make this the easier experience possible. So we focus in B2C and B2B. And in the case of B2B, not only on e-commerces, but also on some offline commerces that need to ship. We are Madrid-based. We are on Series C currently. We did break even on last December on Christmas peak. We have a really big base of e-commerces, and that helps to ease the seasonality. So we are doing really nice during summer, which is good. In terms of the engineering team, it's composed of 14 people, back-end, front-end, QA, operations, and the company is composed of around 90 people, including sales, customer care, and everything in between.
Okay, that sounds interesting. So maybe Elnar, do you want to give us your thoughts on this?
Sure. Hi, guys. I'm CTO and co-founder of Realeyes. We develop a technology, first of all, that is enabling computers to read human emotions from their face. So any device with a camera, we're able to capture the changes of the facial expressions and analyze them as reactions towards what people are seeing on screen. We have developed a product around this technology as well. That's a marketing product, marketing research product. Basically, we're helping our clients to analyze engagement with their video content, emotional and attention engagement. Usually, these are video ads that we're testing. We can test people anywhere in the world. It's fully scalable, fully online with any device that has a camera built in. All tech is developed in-house, including the computer vision parts. So we have a very diverse tech team. We have web engineers that come with testers and product people. We also have an infrastructure support team. And we do have an extensive R&D team as well, which there are three types of people. There are data engineers, there are data scientists, and there are computer vision researchers as well. All in all, the company is around 60 people today, 35 of which are in tech. I'm responsible for building the tech teams, driving the strategy, and then helping in various aspects of the technology of the company, focusing at different times of life of company, depending on where the needs are. So currently, my main focus is in R&D, but I do oversee our cloud infrastructure development aspects of the team as well. We've just raised 16.2 million as a round or A+ round. and basically featured as Deloitte Fast 50 companies last year as well. All going very well, scaling, and definitely have challenges in that, and lots of stories to share. That's for me.
Sounds interesting. Martin, do you want to tell us a little bit about you?
Gladly. So I'm the VP of Engineering at CompareEuropeGroup. Basically, we are a comparison site that help consumers compare various products such as credit cards, mortgages, broadband connections, or phone providers, and help them find the best offer so they can save money. Our tech team is based in Lisbon, but we have offices in 5 locations in Europe. But we're hiring quite actively here in Lisbon at the moment, looking for 5 roles still. We raised a Series A last year of 20 million. So also quite a big round for a European company. My responsibilities are to build the tech team here, drive the technology vision, make sure that we have a scalable platform going forward, and have a vision that is long-term rather than just short-term.
Okay, Martin, Joshua, that leave us with you.
Perfect. Yeah, I'm Joshua. I'm a co-founder and CTO at Super Awesome. We are the biggest kid tech company in the world. So we work with the likes of Hasbro, NBC Universal, Disney, and so on. And we power a lot of the digital ecosystem for kids. Basically, the technology platforms that sit behind the scenes that keep kids safe online. We are headquartered in London. We've got offices in New York, LA, Chicago, Singapore, Bangkok. So decent global footprint, a little over 140 people. With 15 open roles in engineering alone at the moment, so growing rapidly still. We are at our B stage. Well, I mean, we closed B last year, and overall, I'm basically responsible to try and make sure we spend some time to prepare and structure our engineering team to cope with the accelerated growth that we're going through overall. Make sure that we're kind of one step ahead of the growing pains that we inevitably experience every single day, and at least try to preempt many of them. So overall, that's me.
Okay, I see a lot of companies with location bases in multiple cities. I guess that's a sign of expansion. So I guess it's a little bit of time to go to what we actually like to talk about it. So should we use microservices or should we go to a monolithic system? I can give you a little bit of my point of view, and then I'll let someone else start. So we're currently using like a system of 3 layers. So what we did, we divided between products, services, and microservices. Each one of those 3 layers have a different set of rules, being that the microservice always have the rule of not speaking with each other by interfaces and never touching each other databases, while the services are a little bit more unclear in what they do, because many times connecting and doing integrations with multiple systems outside of our ecosystem that we built can be quite tricky. So it's rarely ever possible to actually do something very simplistic that will only fit one thing. Has to be a little bit of a Swiss Army knife that connects to the outside world. I don't know who has a stronger opinion about that. Why don't we start with Joshua, since you were the last one? Why don't you give us your opinion on this one?
Cool. I'll start then. For me, everything is about agility and speed of delivery, really. If there's anything that at least I think I've learned over the last 5 years, is that what you think you end up delivering is nowhere near what actually is the end product that you're going to be building. So the speed at which you can iterate over your product and the speed at which you can roll it out and get it in front of customers to get feedback as quickly as possible is very, very important. So I mean, we're structured around microservices, and the speed at which you can iterate over each and every one of them individually is, I think, one of the biggest strong points. The second point that comes with it is that I'm a strong believer in Conway's law, which is just the fact that your organizational structure will mirror your actual application structure and the other way around, right? So if you want to allow if you want to allow real ownership and you want to allow people to properly own the various products that they have, they need to be able to iterate very quickly, and they need to have very clearly delineated rules of responsibility. And again, microservices from that perspective allows you a lot more flexibility to figure out how you end up producing the various increments that you go through. So I'd say for those two reasons, or three reasons really, I would err towards the side of microservices.
Okay, I think that kind of took the words out of our mouths a little bit. Eduardo, why don't you share us a little bit of your point of view on this one?
Sure. So really liked Shosha's opinion. From my perspective, the monolithic system is easier to develop to find market fit. So probably at first, you would like to go to a monolith so you can deploy and put in front of your clients as quick as possible, a kind of an MVP. But then if you grow and you need to scale and you need to iterate quickly, then microservices probably are a good choice. Of course, it really depends on the experience of the team and all the accidental complexity that you will get with microservices. Here at Packlink, we use microservices since late 2015. We were really early adopters of the term. I think Shane Lewis and Martin Fowler coined it around 2014. So we went through all the hard lessons of microservices that we are now seeing at conferences and blog posts and everything. So yeah, from my side, it's if you are starting, if you need to find market fit, don't find accidental complexity. Go for the easiest thing. It's probably a monolith, a quick Rails app or whatever, and start having clients and generating some revenue. And later you can scale while decoupling your monolith and starting doing. There are lots of great ways of working with the monoliths while you migrate to microservices. If your team is big or you really need to iterate that fast.
So that's an excellent advice. I kind of agree with that. Unless you have a very strong team of 8 to 12 engineers from day one that you've trusted and you've worked before, and you know you can create that kind of complexity. Microservices is very hard to start. Alexey, do you want to give us? You guys feel free to join and intervene at any point. Alexey, do you want to give us your point of view on this?
Yeah, sure. So I hear what Joshua and probably the rest of you guys are feeling, right? Eduardo. Yeah. Eduardo. Great. So my point is that I've been through several examples, basically, and I've been going through a huge monolith to microservice architecture, been going through microservice from the very beginning full on. So the observation at the moment is that it really depends, right? And you cannot just say, well, if you're in the beginning of your journey, then you should definitely go for monolith, right? It really depends on what is the end goal for you and what is the load, right? And what is the speed that you want to go and what you see as the next upcoming feature or set of features or the products you're going to push, in the nearest couple of months after you gain traction, right? Regarding the Conway's law, obviously this is something that organizations and engineering departments or tech departments, if you will, are affected by. What I mean by that is that you have squads or any kind of units that are intended for delivery of features, right? And inevitably they form their own pieces of the infrastructure or your architecture, right? But at some point it can become chaotic and you would gain a little bit of weight in terms of technical depth. So one way to address that would be to actually have a vision which could be driven by a person responsible, such as a set of principal architects or one architect, depending on your team size and the company setup, and basically build teams around that vision, technological vision as well. So I think that way you kind of can be on the safe side in terms of introducing something that is inevitably going to be thrown in the trash, which is unfortunate sometimes, but also with microservices, this is very easy to do, and as long as your architecture and basically your setting allows that, right? So it kind of takes a lot of discipline and a lot of trust in each other, and this is something that companies, I think, should exercise.
I mean, a lot to think about here. Elnar, do you wanna give us your take on this?
Sure. I do share the sentiment of the previous speakers. So basically the path that we went through is that we started with a monolith, and we're now trying to migrate to microservices, but we're at the very, very beginning of that. We have experience of all the troubles that the monolith creates. And I think, first of all, I do want to confirm that when, very often when you're starting with a small group of people, and you're starting with something that you don't know if it has a market fit. And that was our case. And so for us, monolith was definitely the best choice to go forward with. It allowed us to quickly iterate, and we've iterated a lot through all different features of the product, and the whole product itself. And we pivoted as well several times. So this is where monolith really helps, because everything is in one place, data is in one place. It's easy to try out new things very quickly. But as the monolith grows, your technical teams grow. You basically cannot have everyone in the team know everything about the monolith. So you have to kind of start splitting teams into their specializations. And when you split the organization into technical teams, the monolith doesn't split that well with it. And this is where the trouble starts, because teams start having a lot of interdependencies, and then when they want to make any changes, for example, to the database, then they have to coordinate with each other, and then suddenly, you being very agile and fast and quickly trying things, you become very slow and sluggish, and everyone has to agree with each other, and people are arguing why a certain change cannot be made because it will make other things blow up, and that creates a lot of delays as well. So
in that sense, just a quick question, since I think that goes very much into also what part is the biggest challenging of transition from microservice from monolithic into microservice. And did you saw that point? Did you understood that the monolithic was going to grow? And was there a point where you said, if I don't change it now, I know that it's going to bite me in the ass in the next 3 months? And nevertheless, did you still let it bite in the ass?
Yeah, I think we do still, and we still haven't made that extremely firm decision. I think important point to decide is when you are settled with your product, you see the scale up coming, and you know that, okay, you will need that organizational scale up as well, and you need to have an architecture that scales with it. And the other important decision point is with the monolith, you have the technical depth growing. And beyond a certain stage, it's better, once you past a certain point, there's basically no way to do a migration from a monolith where you're taking it apart piece by piece. You almost have to build a second version of your product in parallel and make an investment into that. So I think it is a very fine balance that you have to find there, and it's not easy to do because the product is obviously pushing for new features as fast as possible, and migrating from monolith to microservices, depending on how late you are in that stage, is going to take a lot of resources. And then it becomes a challenge there to try to agree with everyone in the company how you're balancing that.
Yeah, I couldn't agree it more. I think at Pomelo, we took the risky decision, or I took the risky decision at some point, even when people didn't really saw the technical depth and how it was going to grow, but they had an enough understanding that that was a thing and that was unstoppable unless we did something. So we did that transition, but we decided not to go full microservice, because that remembers me a little bit of the sort of Netflix that went from a monolithic system to a microservice, 500 microservices. That was a gigantic pain in the ass just to create all of those interfaces and communicate with each other. Paweł, do you want to give us your take on this? We've been muting you for too long.
Yeah, sure. Actually, at Pusher, we have both a monolithic system and a fairly service-oriented system running in parallel. The original channels product is the monolith. It runs it's deployed as separate services. It scales well. It can handle hundreds of billion messages per month. So it's all good. We're happy with that part, but we couldn't really build new features because with monoliths, the biggest problem, in my opinion, is there are lots of implicit dependencies in the code. And if you're trying to untangle those dependencies, for example, if you want to change the authentication system, how do you kind of split that part out if you don't really know what depends on it? It's a very long process and very dangerous if you're going through a code base that's used by hundreds of thousands of developers, in production. So for me, that's the biggest danger, and that's why we set out to build the second platform for new products, which is designed in a way that has lots of more explicit dependencies, which model how we want the company to look like in the future. As Joshua mentioned, the Conway law, we did the kind of inverse way, the inverse Conway law. So in the Conway law, the companies replicate their structures in their systems architecture. We did the other way around. We built a system in a way that we wanted the company to look like, because we had just a few people working on it. And since then, as the products were going, as we were adding more things onto the platform, we kind of started building teams around that structure, which has served us quite nicely. And we were able to reduce this kind of uncertainty of breaking out certain parts or modifying them, or giving even individual teams freedom to build little monoliths inside that platform if they cared more about iteration speed early. So yeah, that's pretty much my take on the problem.
I see. Martin, do you want to give us your point of view?
Sure. So first of all, I recognize a lot of what people have been talking about. We have been in a very interesting transition phase at the moment, where due to some organizational history, we started out having essentially 4 teams with separate governance of their piece of code. And all of that, those pieces had the implicit dependencies that were very hard to know about. So it was sort of like we had 4 services that together form one monolith. And we faced the issue that when we started to deploy things, various pieces would break around the platform that would be seemingly unconnected, but for some reason depended on the piece of code that was changed. So right now we are kind of in the process of switching from the 4 separate services into a proper microservice architecture where we have proper encapsulation and proper interfaces that are well defined. And this has really brought with a lot of complications because we're taking an overly complex system and trying to make that less complex, which means we had a lot of configuration hell going on, and we've really tried to kind of run into all the roadblocks that come with microservices one after another. So it's been a frustrating experience, but on the flip side, we have seen that we now have more solid deploys so that when we deploy something, we don't suddenly have the platform crashing.
And what do you guys think? Is there a way, probably for some of you more experienced ones, is there actually a way to measure how many microservices is going to exist? We're always talking about a startup, so we're not talking a massive company that has product managements and analysts and project managers and assistants underneath it to create all of that documentation. We're talking about in the startup, what is a realistic system? So Martin, you were talking about that you had 4 services, correct? More or less seamlessly integrated that created a monolithic. So you have any idea where you're going to end in terms of microservices?
No idea, really, no. We're sort of analyzing the platform, and then when we see something that we can logically split out, we try and take that piece of code and move it up. And we try not to do it. Sorry?
So ad hoc. You're creating microservices ad hoc, but always following the very clear rule of encapsulating the databases and only communicating through interfaces.
Yeah, exactly.
And I wonder, is that like a thumb rule that needs to be absolutely followed? Because I found that they can be services that in the hands of very experienced people or very intelligent people, especially developers and senior developers, can actually be little Swiss Army knives. Because then that leads us to another thing. Microservice is beautiful, but then you have the product management, the entire sprint and the entire planification that comes from behind it. And how do you aggregate things into sprints? Is it by people, or is it by product? Is it by microservice? You're going to have 100 sprints. You're going to have one sprint with one architect. What do you guys think? Alexey, what's your take on this one?
I'm trying to parse for myself what was the question exactly, but I'm going to try anyway. So basically, you're talking about how are we going to, what is the way of keeping sanity in the number of variants of the microservices and kind of keep it under a certain level of control so that we don't shoot ourselves in the foot in the end. Is that correct?
Yeah, that's a great summary. Okay. Not that I really knew about the question that I was going, but I was wondering about the complexity and where we're going to get into numbers. And that led me to think about the planification.
Yeah.
How two things work together.
Yeah. I think it very well will repeat what I said, but in my first reply, but I'm going to go a little bit more into details and share my experiences from the past and what we were doing here in AppLift right now. So in order to avoid that, you can apply certain either processes, or you can start measuring your project by different KPIs, such as code complexity on the unit tests and so on and so forth. But essentially, there should be a certain level of discipline, forced or not forced, in a way of having a trust between the teams or in the team. But it's very hard to do so in the very beginning. For example, if you start microservices full on, you're going to go through a long path of aligning on many different things that are the attributes, inevitable attributes of the modern distributed systems, such as the way you do logging, the way you send the messages, the way you trace requests throughout the system. All these apply certain structures or conventions. So what we did in AppLift before starting a new project recently, by the way, so we came up with a set of guidelines that were going with, and we worked on this for quite a while, about a couple of weeks, and it's all on GitHub, so it's a great setup for suggestion changes and having a discussion around that. And you can basically just trace the reasoning behind a particular statement and understand what led to that. But then once you are on the rails, so to speak, right, once your project starts off and it starts generating revenue and you have traffic, then any change that kind of doesn't fit those guidelines, right, that will raise the question, how well does it fit, right? So what can be done, and what we do is we have certain meeting every Monday. It's not compulsory, but when we have agenda for that, then we talk about technical things, such as something that disrupts our architecture or something that doesn't fit our vision. So we call it the committee, and the committee is moderated by designated architect, and all the concerns are addressed, and we have a discussion. And when we make a decision during the committee, so we also take it already in, right? So we try to address any impediment that can be imposed by this change. And if it does fit in the next sprint, right, or in the next two days or 3 days, because we work on Kanban at the moment, then we just take it on. If it doesn't, then most probably we're gonna go in a way of starting a proof of concept, right? So basically, a person who raises the concern, or maybe we form a kind of meta team for the time being of proving this particular change. Interest is that putting some measurements in place and basically proving that it's viable change. So more or less, it's a collaborative responsibility, right? But we have designated architect for helping us understand where we're going and why.
Paulo, you're muted at the moment.
Yes, sorry. Did any of you guys face any kind of those challenges while migrating from monolithic to microservices in terms of the planification was getting left behind, either because of too much complexity over it or just lack of proper thinking?
Yeah, well, I mean, we are on microservices here at Packlink, but the monolith is still alive and kicking. So we basically been 2 years already into migrating, and the monolith is still there and making money. So you cannot kill it, and you have to little by little move all the business logic that has evolved into there and into all that technical depth you have. So for us, we set up a certain kind of rules for creating microservices. Basically, it's trying to find the right responsibility before creating a new microservice. It's that, do you really need a new microservice, or this feature fits within the responsibility of existing ones? We currently have around 20-something, 30-something microservices. I expect that we will go to probably around 60, because there is a part of the system that we need to, that got a lot of responsibilities that needs to be split up. So we use a fixed set of instructions, whether a new feature is within existing microservices or has to be a new one. And we also use the architecture decision records technique to let you know these conversations that happen when you are taking a break or something. So everything is on GitHub also, so you can check, decisions taken by the team and informal conversations or formal ones. But we did make some mistakes while migrating to microservices. We have a couple of microservices which have too much responsibility, or a responsibility which is not the one that was originally thought, because then, system evolves, the company evolves, and then you find out, oh, I have this microservices called A that is not really doing A, it's doing B and C. So probably I need to move this to B and create C. So even if for a small team, because Packlink engineering team is small for having microservices, but then a feature probably might not involve that many microservices, maybe at 1, 2. Our architecture is event-oriented, so basically it's quite decoupled in that sense. So we are able to create a new feature by affecting only the front end and maybe one microservice, or a front end or 2 microservices at best. So I think one of the great difficulties of microservices, apart from the technical ones, are finding the right scope for that new service, application, call it whatever, that piece, that new code that's going to be on your platform doing and reacting to events. Which are the responsibilities? How much is going to grow? So for example, you have an invoicing service. Okay, so when people is paying, who has to send the order of paying? Has to be the invoicing, has to be a proper billing mechanism, has to be an event. Can it be asynchronous? Does it have to be synchronous? Do you really need a transaction? So all those things go in the mix when you are moving away from microservices, because on the monolith, everything is running on the same time probably, and then you have this big transaction for when someone is buying. But when you extract that and you have a lot of business logic, and then you have tons of microservices going out of there. So yeah, for those that are starting to migrate, take a step back and look into really which the responsibilities of each of the services you create, because maybe you can think of them beforehand. But that's a plan, and we know that plans do not survive going into reality, right? So you have your plan, then you open the chest, and boom. So you need kind of a guideline you can follow.
Yeah, I think that I joined very much what Eduardo was saying from that perspective in terms of really moving it over. One of the things that I was that I don't necessarily agree with that was said earlier was, I think, Elnar, where you were talking about that you inevitably have to rebuild your entire system if you move from a monolith to a microservices architecture. I'd say that's probably, at least in my experience, that's a mistake we've made way too often, where the scoping, as Eduardo was putting it, is really important, but it's important in both ways. It has to be defined enough and clear enough so that the service operates on its own, but it also has to be small enough that you don't take the big kind of release party risk, right? Where everything goes live on the same day and you inevitably will have missed something that it is not doing simply because the task is so big. One of the patterns that we've followed a lot, kind of as we, even just as a microservices ends up growing and growing and growing, and then you decompose it into different microservices and so on, is basically first kind of building out an adapter, funneling back its own services, and then rewriting them one by one until you have a full microservice that operates on its own, and only then flipping the switch at that point in time to really let it handle it itself completely. But yeah, I would suggest that you can rewrite a monolith into microservices while staying up, whilst keeping your existing system, and then over time you will end up with a different architecture. Now, I completely agree that has a toll in terms of the timing that you take. So it is you're trading off the robustness of what you're building with the speed at which you're able to operate, I would say.
Yeah, one of the challenges that we're facing now in this migration process is really splitting up the database. So the biggest part of the monolith is the database itself, and we have the structural information there, which you do want to have in the relational kind of setup. Then you have the operational part of the database where you're storing all the events, everything that's happening as your product is working. And then you have the analytics and the analytical part of it, where you need to analyze data, but you want to also experiment with it and so on. So a lot of it, you don't want to store in the same in the same structural setup. You want it denormalized. You want another engine to use it, and splitting that up is really a challenge, because you have to really basically almost run multiple databases in parallel and keep them updated continuously at the same time, while you're then migrating some of your services into this new database setup. And then once the migration is over, then you kind of flip the switch to enable it running fully over the other database, which becomes the primary one, and the other one becomes like a secondary backup that you keep running for a while, and then you gradually phase it out. And there's, it's maybe easy said, but in reality, it's quite complicated, particularly because it does require resources. B, you're kind of losing this synchronicity of the database. It all comes down to the kind of eventual synchronization between the databases. And you then have to put special pieces of the architecture in place to cope with that and make it robust against maybe some parts of the data not being immediately synchronized. So that's kind of one of the pains that we're going through.
One thing I wanted to add, that basically to what Elnar said, all is right. I mean, you can try to minimize the efforts by employing such technologies such as CQRS and front, and then use event sourcing to persist your database caches, for example, right? But you really need to plan ahead the time that one microservice part will take you to implement, because imagine that there is a product requirement that needs to be pushed just right now and the next week, and you'll end up implementing this twice, and it will be very hard possibly to maintain two implementations in parallel and then making sure that everything can sync. So yeah, one thing to think about is having a very solid automation testing base on your APIs and your flows and so on and so forth, and start investing from the very beginning into that.
On this note, this is something we've been trying very hard to do as well, to specifically avoid the rebuild and instead make sure that we iterate on the core product. So essentially the process we're going through is that we identify a part of the application that we think we can kind of isolate. And the first step is, of course, to make sure that we have proper integration tests in place so that we know that we're not messing up the public interface. And then the first step after that is we make sure that we maintain the same database structure, even though we are moving it from the central database. Because then once we have the exact same system running on a separate database with our test passing, then we can then start messing with the internals and optimizing that. But I think if we were to rebuild entirely from scratch, or like a second system, the complexity of our application would just mean that we would miss out on some of the business logic that's in there through many years of knowledge.
Yeah, I just want to clarify. I didn't mean to kind of suggest that that's the right approach. I was rather saying that if you let it last for too long, then the technical depths grow so much that it becomes almost a mission impossible to build it apart. And you just want to make sure that you don't miss that point.
Yeah, and I think we probably did go a little too far in too much technical depth.
So basically, that's point
I don't
of
think
return, right?
I don't think nobody is able to not go too far in the technical depth. We all see it coming. but we can't do anything to avoid it. I always say that engineering is kind of like a boat. You do want to turn left, but that's not going to turn left right away. It's going to take a little while. It's kind of like slowly, you see the iceberg, but you know you're still going to crash. So you prepare yourself as much as you can for the crash. On that note, I would say that one of the advices I would give to any startup that is trying to think about this situation of going from a monolithic into microservices, two, for me, very important points, that is timing. So know your strengths, know your team, understand the vision, the end vision, understand, at least have an idea of how do you see those end service, just microservices going. What's your plan in 1.5 years? How do you see your business units or your departments or your product being separated? And the second thing I think is incredibly important with microservices is monitoring. And on that note, of course, monitoring is essential for microservices. Otherwise, you don't even know what went wrong, what blew up, what didn't blow up. And many times finding out who spoke to who is kind of a detective job that will take like a half a day to a developer. That's never good. They should be able to find the right information pretty quick. And on that note, I leave with what's probably what most of you are gonna be against me, but I do not truly believe that microservices have to have encapsulated databases. I do believe in a shared databases as well as long as it's well defined into its context, each one of the tables. I do not see that importance of communicating two interfaces alone. Not saying you cannot do it, but I'm not saying that I don't believe that is a thumb rule that you have to do it, otherwise it's not a microservice. What do you guys think on that?
Well, from our side, we do not share the database. We do not only share APIs within microservices. So we basically have a couple of orchestrators that we call that they actually need to call other services to do their work, but they're just a couple. So we rely on the eventual consistency and what today is called, I think, is forgot the name, sorry. So yeah, every microservice has a kind of a copy of the data, and they have the view they need of that data. So we have replicated the information several times, and we don't care about the eventual consistency because it's a couple of seconds, and then the information is going to be where it needs to be. And that gives you all that flexibility that you need, so you don't have this how was called, like heroic deploy, where everything has to be there, because then else it's going to go wrong. So I think that one of the benefits of microservices is that the fact that by not sharing APIs or databases schemas, you don't have to coordinate with the other microservices using that schema. I think that's one of the benefits. So I don't really agree on sharing the database. For me, it's kind of an anti-pattern if you are doing microservices, because you lose almost all the benefits there. If you are using an SQL or even a MongoDB, because if you change a field and you remove it, then the other software is waiting for it. Then you have an issue.
Yeah,
that's actually very. Go ahead.
I would agree overall, although there are always exceptions to the rules. I'd say kind of overall, the default should be a microservice should be as self-dependent as possible without ever needing anything else now. And then there are some exceptions to the rule where you really don't want to be duplicating your data, but that's more the exception than the rule for me.
Can I have a quick poll here? So I see that Eduardo is very much into which Microsoft has his own encapsulated database, and I understand his point, and he's making me think. I hope not too much. I guess Joshua is a little bit with me, like there is exceptions. How many? That's a different question. What about the rest of you guys? What do you guys think? Paweł.
Yeah, sure. For us, there's not much we can share between the services when it comes to databases, mostly because the services are owned by separate teams. And you don't want to be put in a situation where, for example, service A gets spammed by some customer. They cause quite a lot of load on the database at 2 a.m. on Friday night. But they share the database with Team B, and the Team B has slightly tighter latency requirements. So Team A doesn't get woken up at night, but Team B does, and it's not their fault because their service is running okay. So in this case, we need a fairly strong separation between the databases. However, like in general, like I'm not a big fan of sharing databases between services, but there are different levels of isolation, and some of our services that we have within an individual team, they might share the same RDS instances, for example, or a physical database, but they're going to use separate, relational databases within that kind of RDS instance. They might use separate tables, but as long as there's a clear ownership of that service, that database, it's kind of okay.
I think isolation is the right word, but you can achieve isolation by many ways. By code or by ownership. True, by code is always better, but Martin or Elnar, what do you guys think? Someone from my side. This is going to be a long next 6 months.
We try very, very hard to make sure we have isolation on a data layer as well. It makes things much easier when it comes to both organizations, management, and deployments and performance. It helps. I would say though it's very, very application specific, but as far as possible, we always try to separate out.
Well, I'll add from my side is that definitely for separation. Now having the challenges where the analytics team is scared to run their analytics because they're afraid to kill the server that some other services are dependent on. That type of scenario, and that happens between multiple teams, not just the analytic teams. Also the deployment, one team wants to introduce a new feature and the other one says, no, that's going to kill our part of the product. So definitely think, ideally the services should be independent on the data layer. But that's within reason, right? So if you don't have any good reason for making that separation, then why complicate things for yourself and for the team? So basically, you need to see where it makes sense and apply it correctly. But don't go wild and absolutely separating everything out there, whether you need it or not.
We'll see. We'll see how wild we'll get. Okay, that definitely gave me a lot to think. On my side, I think we are pretty much close. Thank you, everyone.
Thanks, Paulo, and thanks to our audience at Facebook Live for watching us live, and those of you that are watching the recording, thank you for watching this episode of ScaleUp Heroes. Special thanks to all of our panelists. You guys were great. Visit our website at ScaleUpAcademy.io. You can learn more about us and what we do, and if you find these live shows valuable, we hope that you'll hit that like button and share today's show. And join us every Monday for a new episode of ScaleUp Heroes. Have a great week, everybody. Thanks.
Bye, guys.
Thanks, everyone.